Hi, this is Mr. Forster, and we're going to learn about exponents this week. And exponents are repeated multiplication, and here's a nice graphic that shows that. We are in distance learning, week 3, and you can refer to these slides while you do the work in Khan Academy. And a special thank you to my wife for doing the slides. And so, exponents. Exponents represent repeated multiplication. And exponential functions grow very quickly. And so they are not linear, they're not straight lines, but rather curves. You know, we've talked about the parabola before. But they're not straight lines, they're curves, and so they're not linear. Exponents being representing repeated multiplication, you could expand this x to the 4th power. This is called the base, x, and this is called the power, 4. This whole thing is called the exponent. So x to the 4th power, and that's x times x times x times x. There are 4 x's multiplied. That's not 4 times x, but x times itself 4 times. And here's 2 to the 3rd power, which is the base is 2, so we multiply 2 times 2 times 2 3 times. And this 3rd power has a special name. It's called cubed. 2 cubed because it's 2 to the 3rd power. Here we have negative 3 to the 2nd power. That's negative 3 times negative 3, which is 9. A negative times a negative is positive. We have negative 3, and this power of 2 right here is oftentimes called squared. Or you could say negative 3 to the 2nd power, or negative 3 squared. And then down here, oh, let me go back up one more. We have negative 3 to the 2nd power, but this negative, and I'm going to try and get this out of the way here. This negative 3 to the 2nd power, without the parentheses, we can see a negative 1 that shows up in front of that, and so that is actually equal to negative 9. I'm sorry that it's typing over that, but without the parentheses, you have to be careful because it represents a negative 1 there. So my apologies for the toolbar showing up. So just whether a number is positive or negative, we know that an odd number of negative signs will give a negative result. For example, just in 1 negative sign, and of course the number is negative, and 3 negative signs, because a negative times a negative is a positive, times a negative would give us a negative. So 3 negatives would be a negative, 5 negatives, 7 negatives would be a negative. And for the same reason, an even number of negative signs will give a positive result. So we know that negative times a negative is a positive. If there were 4 of them, we'd have 2 pairs of negatives, so that would be positive again. So this could be 2 or 4 or 6 or 8 or 10, and we know it would be positive. And so information, we can tell the sign of what the result will be just by how many negative signs there are. In this case, there's 2, so it's going to be positive. Just kind of checking for understanding, and this will be negative or positive. So here we have negative 7 to the 3rd power. There would be 3 negative 7s written out. So since there were 3 of them, that's odd. The result would be negative. Negative 9 to the 4th power. Since we'd have 4 negative 9s, and 2 of them together would be positive, and 2 more would be positive. So this would be positive result. We don't know what it is. It would be 9 times 9, 81 times 81, whatever that is. And just remember that this, without the parentheses, that is going to be negative because that's really negative 1 times 9 to the 4th. So that there's an invisible 1 there. So whatever the 9 to the 4th equals, it's going to be negative because of that negative 1 being the last thing. And so let's talk about 0 and first powers. Something to the first power, a pretty easy concept. The first power is an invisible 1. Oh, x to the first power, we don't usually write it like that. We usually write it just x. There's an invisible 1 right there on the x. It's x to the first power. So if you don't see something there, you know it's to the first power. So 5 5 equals 5 to the first power. We usually don't write the first power, but it is really there, just invisible. Easy concept. The 0 power. Anything to the 0 power is 1. And we can prove that, but just take it, we'll prove that later with powers of 10. But right now, if you see something to the 0 power, it's 1. 5 to the 0 power, 8 to the 0 power, x to the 0 power, all of these are equal to 1. This is a little bit of a trick because this is negative 5 times x to the 0. There's an invisible dot there. And so that's negative 5 times 1, which equals negative 5. And an exception to this rule is 0 to the 0 power. That's 0. We might even call that undefined. And then powers of 0. 0 to any power is 0. Of course, we take the 0 and we multiply by itself one time, or we could go 1 times 0. That's 0. And 0 times 0 is 0. So whatever the exponent is, when there's a 0 base, the result will be 0. And if we multiplied this by 10 things, when you multiply by 0, the answer is 0. Let's talk about exponent rules. Go backwards here. Adding and subtracting exponents. So we already know this. It's called combining like terms. So adding exponents, we're just going to remind you, I'm just going to remind you that here we have 1x squared plus 1x squared is 2x squared. So that's combining like terms. And this right here, well, x squared plus x, you can't do that because those are not like terms. You remember we played with the algebra tiles earlier in the year, and the x squared, of course, was an x, a square, and the x was a stick. So you can't add x squared and x. And here 4x squared minus 5x squared, we just subtract the coefficients here, and that's negative 1x squared. And so we've already done that, and we're not going to do that this week. Just a review that we already know about adding and subtracting exponents. Yeah, it's called combining like terms. Multiplying exponents. I have a saying, when in doubt, write it out. And so here we have x to the 5th times x to the 3rd. And I'm going to write it out or expand it. And I see 5 x's and I see 3 more x's. And if we just counted how many there were, there'd be 8. And I think to myself, well, what's the relationship of 3 and 5 and 8? And then I'd say, well, you add 3 and 5 and you get 8. And so the exponent rules for multiplication is easy. If they have the same base, and they do here, they're both x bases, we just add 5 plus 3. And so that's an easy rule. But there's lots of rules, so you have to remember them. So multiplying, you just, with the same base, you add the powers. You add the powers when multiplying exponents. So here we have 5 to the 3rd times 5 to the 4th. Well, I can add that together. That's 5 to the 7th. I expanded it here, but as you get better, you don't really need to expand it. You just say, oh, that's 3 plus 4. And so negative 2 times negative 2 to the 7th. Remember, we have an invisible 1 here. So we have 1 plus 7 is 8. A lot of people would say, oh, this is negative 2 to the 7th. No, there's 1 negative 2 here, and there's 7 here. That's negative 2 to the 8th. Do not multiply the bases when multiplying exponents. So a lot of people on this particular problem, by the way, they would say negative 2 times negative 2, that's 4. Well, no, you don't do anything to these bases. This is not 5 times 5 or 25. This is not, you just add the power. So 3 plus 4 is 7, and leave the base alone. And here, 1 plus 7 is 8, and leave the base alone. Okay, so those are the multiplying exponent rules. Power of a power. Here, see, we have a power of a power, or an exponent of an exponent. Well, this is x to the 3rd power to the 2nd power. So that means we'll write this x to the 3rd twice, and when in doubt, write it out or expand. And I do like that on these types of problems. So I'm going to write this out. There's 2 of them. And then I'm going to write 3 x's here and 3 x's here. And if I count them, 1, 2, 3, 4, 5, 6 x's, I say, well, what's the relationship between 3, 2, and 6? And I say, well, look at that. If you multiply, you get 6. Oop, I didn't mean to change that. So we, here, when we have a power, we multiply the bases. So powers of powers, you multiply. So here, 5 to the 3 to the 4 is 4 of these 5 to 3s, and if we added 3 plus 3 plus 3 plus 3, we'd get 12, but after you do it a while, you say, I don't have to write it out. I can just multiply 3 times 4. But when in doubt, write it out. And so this is 5 to the 12th power or 5 to the 12th power. Either way you do it. Next, power of a quotient or a fraction. So just remember that when you've got a power, everything gets that power. So even in this fraction, so there's a 2 that gets the power of 3 and a 3 that gets a power of 3. And we can remember that just by writing this out. And if you multiply fractions, you multiply straight across. So we have 1, 2, 3 2s, and we have 1, 2, 3 3s. And so this is really 2 to the 3rd and 3 to the 3rd. Notice I wrote it here. And that's 2 times 2 is 4 times 2 is 8 to the 27th power. Now, they could be a negative, and if that was a negative 2 thirds to the 3rd power, that'd be 3 negatives, so that'd be negative 8/27. So it says distribute the outer power. So here we have 3 times 2 is 6. 3 times an invisible power of 1 is 3, and 3 times 5 is 15. But when in doubt, we could write this out, this 2x squared over 5. We could write it out 3 times, and then we could see there are 3 2's and 3x squareds, which is 6, and 3y to the 5th, which is 15. So, again, a little bit of a tricky concept, but distribute the outer power to everything inside. Exponent division. Well, with exponent multiplication, we add the powers. So math is very symmetrical. So if we're multiplying, we add the powers. You might guess that when we divide, we subtract the powers. And I can show you that. So here we have x to the 5th over x squared, or x to the 6th, sorry, x to the 6th divided by x squared. Or I could write it like this, divided, but it's a fraction. And a lot of people might say, well, 6 divided by 2, that's 3. But let me show you, when you expand it, we have 6 x's here on the top and 2 on the bottom. And if I cross them off, because they're the same value, how many x's are left? 1, 2, 3, 4. There are 4 remaining, because these x's cancel each other out. And so that's x to the 4th. So you say, well, wait a minute, 6 minus 2 is 4. So that does confirm the property that division, we subtract the powers. So here we have x to the 6 over x squared. 6 minus 2 is 4. Here we have 5 to the 8th over 5 squared. And what's 8 minus 2? Well, that's 6. So a pretty easy rule here. Again, don't do anything with the bases. It's not 5 divided by 5. It's not 1 to the 6th power. It's 5 to the 6th power, because we're crossing off multiples of 5. So you subtract when you divide. And so what about negative exponents? What about this case where we have more x's on the bottom, Mr. Forster? Well, let's expand it, and we see that we have more x's on the bottom by 3. So I'm going to write my x on the bottom with the power of 3. We should have crossed off that x there, and it's crossed off. So there's nothing left on the top, so we have to put a 1 there. So this is 1x to the 3rd. But what is 2 minus 5? Well, that's negative 3. So that tells me that this 1 over x to the 3rd power is the same thing as x to the negative 3rd power. It means nothing about a negative number. It just means that this x is on the bottom of the fraction. If x cubed is on the bottom of the fraction, if we move it up to the top of the fraction, you'd see it has a negative sign. So we can imagine an invisible fraction bar here. This moves up and it changes its sign on the exponent. But x to the negative 3 is the same as 1 over x to the third. So the negative exponents are not negative numbers. They represent exponents on the other side of the fraction bar. So 2 to the negative fourth, you see this invisible fraction bar here. That's actually 1 over 2 to the fourth. We have to move this down, and then something has to be on the top of the fraction, and we're going to say that's a 1. And conversely, this 1 over 3 to the negative fifth, well, that is the fraction bar. So if we moved it up to the top of the fraction bar, and there's the fraction bar that's invisible now, it becomes a positive exponent. So again, nothing to do with positive or negative numbers, just on the different side of the fraction bar. All right, so what about this, where we have a power of negative exponent? Oh my gosh, this is so confusing. Well, remember, everything with the power of a power gets multiplied, so I'm going to do that. And so I get negative 5 times negative 4. Well, that's positive 20. And 3 times negative 4, well, that's negative 12. But we could also write this, since that's a negative power, we could say that that is actually x to the 20th times y to the 12th. So this negative 12 power actually moves this negative 12 here, the y to the negative 12th, up to the top of this invisible fraction bar. And so that, ladies and gentlemen, is the end of the lesson, and thank you so much for paying attention. You can refer to these slides during the lesson.